on-chain birds family and friends. Here with an explainer video to go over some of the concepts discussed today in the Twitter space in relation to hashing, SHA-256, and how we are going to prove to you, the buyer, that the Bitcoin cow that you receive was truly random and distributed in a fair manner. And this is going to be a little bit technical, but I'm going to try and make it as easy as possible to understand, and the reasons why we are doing this. Hopefully we are the first, if not one of the few people or projects to go down this route for Bitcoin Ordinals, and we think it's a very important step in ensuring that BTC and the NFTs that are created on BTC are fair, because there are too many unfair scenarios in Ethereum, even though it has the capacity to make things more transparent. So you can imagine on a blockchain like Bitcoin, where there are no smart contracts, a lot of cowboys are going to be out there maybe being sneaky and ripping people off. So the reason why that we need to come up with a different technique to prove this randomness is because, as I mentioned earlier, Bitcoin doesn't have the ability for smart contracts to have these advanced pieces of logic like we do for the on-chain birds original contract, and then also the enigmatic boxes for the opening of the boxes. With the randomization on Bitcoin, like the worst case scenario, so just making assumptions that people are doing sneaky things, or let's say if we were, right? Of course we're not, but you can imagine that even if we say that the ordering of the addresses that we've collected is randomized, and let's say, for example, after the randomization, I was in position 1, you were in position 2, and Rem was in position 3, it's very possible for us to reorder the actual collection of the ordering of the cows themselves, so that I, as in position 1, get the legendary cow because the cow was also in position 1, and you in position 2 you get a common one, and Ren in position 3 gets like the mythical one. That's very possible, and we don't want that to happen. And don't forget that since the Bitcoin cows can't be generated at runtime on Bitcoin due to the lack of smart contracts, these have to be created offline. You might ask or say, why can't they be created on Ethereum first? And that's a valid point, except that there are two issues with that. One of the issues, or maybe three issues. The first issue is cost. So by creating it online, on-chain, on Ethereum, there's going to be quite a bit of cost. The second issue is that if we mint the collection on Ethereum first, then everybody will be able to see what they look like. So there's a risk that somebody might take all 10,000 of the generated cows and then inscribe them on Bitcoin, which that would be the worst outcome. And the third reason is that if we were to mint them, create them on Bitcoin, on Ethereum first rather, then it's not really a Bitcoin native original PFP, because it's being created elsewhere first, then ported. So it's like it's pretty much the same as an Ethereum collection being ported over onto Bitcoin, which many collections on Bitcoin, that's the path they follow, and we don't want to do that. So then if we are generating these 10,000 cows offline or off-chain, then how do we prove to you that we didn't keep regenerating the 10,000 until we got like a favorable outcome, a favorable ordering that matched up with the addresses, so that I got the good ones or Ren got the good ones, and and everyone else got common ones, right? Because that's very possible. So even though the randomization of the distribution address is finalized, we could then use that to regenerate the collection side until we got a good sequence of cows. So we need to address that problem. I know that everybody out there, you trust us, and that's fantastic, and we thank you very much for your trust and all the support you've given us, but that's not the point. We're here to set better standards. So because you trust us so much, I think in a way we want to prove even more that there is a correct way to do things. Okay, so we're going to move on and talk about how we're going to achieve this. So if we look at the Bitcoin Cows Ethereum contract, here it is here. And if you go into the contract button on Etherscan and you scroll down to the Solidity code for Bitcoin Cows, which is file number 4, and you will see a lot of good dev comments, like any good dev should. It's very well documented, and I've already highlighted it here. So there's a comment here that says SHA-256 concatenation provenance hash public before randomization, and that's a very important point to note. And this is the actual variable name. It's called Provenance Hash, and if you go to the read side of the contract, there is of course a get method for provenance hash, which at the moment is empty. Now, what does this serve? What is the purpose of having this? Okay, so let's have a look firstly at SHA-256 and what it does and what it's used for. So I've got the SHA-256 tool online. You can find this by typing in SHA-256 online tool. And what this does is show you, because SHA-256 is a hashing algorithm. It's one of the most popular ones out there. And what it does is it takes an input and then it scrambles it for you and produces an output. So if I put in here the word dog, then it comes up with this particular hash. And whatever you input will always give the same output every single time. And it's also one way, so you can't get this and unscramble or decode it to get whatever the input was. Now, the interesting thing here is that if I add an S to make this dogs, some people might think that maybe the end of this might change a little bit because all I'm doing is adding a letter, right? But actually, no. I put in an S and the whole thing changes. So this is what this hashing algorithm does. And no matter how many characters you input, it always gives the same output, length of output, right? So this is the hash. And if we go back to the contract and go into the code again, it's saying that we will provide a hash, a provenance hash, and we'll make it public before randomizing the cows. So in other words, there will be one of these values written in to the contract so that everybody can see it. And the actual method of writing the hash in is also a transaction. So it'll be timestamped. So you know exactly when it was done. And that's very important as well. So you can see that it was done before the actual randomization of the cows themselves. So what will this particular hash that's stored in this contract be comprised of? So if, in my example, the hash was the result of putting in the word dog. But the hash that's going to go into this contract serves a very important purpose. And that purpose is to show you that the 10,000 Bitcoin cows that were generated off-chain are of a very specific order. Okay, so that might be a little bit tricky to catch, but I'm going to give you another example to make it a little bit easier to understand. So imagine that there are 10 cows. So you can extend this to any number, but I've made it 10 to make it easy. So we generate these cows off-chain, and the original sequence of the 10 cows by rarity is this ordering. Common, 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 uncommon, 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 rare, rare, whatever. So this particular ordering, and this is just as an example, if I put this into the hashing algorithm, we get this output. So what that means is if we put this into the actual contract, so if we write this in there and you know that at a particular timestamp, Ren wrote this particular value, which you can retrieve from the contract. So let's just assume that this was written in here. Then at a later point, we could say that the original ordering of the cows was this ordering. How do you know that we're telling the truth? Well, you would get this, put it into the hashing algorithm, and compare the output to what's written in the contract. And if they match, then we're telling the truth, because whatever you input into this algorithm always gives you, if you input the same thing, gives you the same output. So I hope that makes sense. Okay. So once again, if this is the ordering of this is a very simplified example. If this is the ordering of the cows 1 through to 10, and these are the rarity ranks or traits or whatever, then this as a hash equals this. And this written into the smart contract proves to you that indeed this was correct. Okay, so that's one part. So that's step one. Now, we're not going to hash words like this because that doesn't really make sense, because you need to know that the exact Bitcoin cow that you received, which is an image, right? An image was in a particular order. So imagine you replace this with 10 images. A common image of a cow, another common. But even the common ones have their own different traits, right? So how do we now replace these with a representation of the actual NFT, the image? Okay, so if we go back to an earlier video that I may have produced, we talked about having an image. In the case of the previous video, it was SVG, right? So the image had code behind it, which the browser would render ultimately into the image that you see here. But that was the case for SVGs. The Bitcoin cows are not going to be SVGs. I believe they're going to be either PNGs or another format. But anyway, you can't do like a browser view source to get human readable code that says draw a rectangle here of orange color, draw a rectangle here that's blue color, right? If you refer back to my previous video, that's how the SVG renders on the browser. But every file at the very lowest level is just zeros and ones because it's a computer file. So this PNG file also has code behind it, albeit not human readable. So what we can do is get this particular file and put it into a base 64 encoder, right? Just as an example. So I've done that here already. So this particular file, when you encode into base 64, becomes this long thing here. Okay, so then if I grab this and I put it into the SHA hashing tool, it comes out with something else. So that's just for one image. So now imagine if you saw this output in the contract, then we said to you that actually equates to this guy. You can prove that we're telling the truth, because you can yourself can get this image, you can convert it to base 64, you can then copy and paste the base 64 into the hashing algorithm and end up with the exact same output that you saw in the contract. So that's now I've explained to you twice how we can prove to you and how you can check for yourself that what you see in the contract is indeed what we say it is, like the input, the original. So then if we go back to here and we talked about having 10 different, in the simplified example, 10 different cow traits. And then I said to you, okay, we need to replace each of these with the corresponding image, didn't I? So that's possible because you just need to do that for 10 different, each of the Bitcoin cows. Just turn it into a base 64 and they'll all be different. And then you can encode them. Then you can hash them. And the way that Ren is going to do it is he is going to do 10,000 individual hashes of each of the cows. So what I did here before was I grabbed one. So this is one image, base 64, hashed output equals this. So let me grab that. Okay, so that's image one. Oh, caps lock. Okay, image one is this. So now there's another image, and I've got another image here for you. All I did was I changed one pixel at the top left-hand corner, and I've done that for a very specific reason. I wanted to show you that making the smallest of changes can actually impact the output in a very different way. So it doesn't look anything like what the output of this one is. So I've also converted this slightly modified image to base 64, and this is the result. And if you want to have a look very quickly, you can see that if I scroll down to the bottom of each of them, that they are very, very different. Okay, the highlight doesn't make it any easier, but yeah, if you have a closer look, it's nowhere near what the other one is. So anyway, so I'm going to grab this second base 64 encoding of this modified file. I'm going to put that into the hashing algorithm, and this is my output. So now I've got two images here. So the first one I've already got, and the image 2 is this. And you can see just by comparing the two, they're completely different. Okay, so we're going to go through this process 10,000 times, and then we're going to end up with 10,000 different outputs. And here's where the magic happens, because what you can do is, and there was a keyword in the contract earlier, and I'll go back to it just to show you. It says concatenation, right? So that means to join things together. So what's going to happen is there are going to be 10,000 of these hashes of each of the cows, and then they're going to be put together. You see that? So I've just copied and pasted one. So the first one there, the second one there, the third one will add, and end up with this massively long input. I know I'm just copying and pasting the same thing, but imagine there's 10,000 different ones. Then you grab this and once again put it into here. And you still end up with a nice, neat, fixed length output. So after all those processes are done, the final hash that you end up with is what is going to be placed into the smart contract. Okay, so I hope that makes sense. Which means that after we randomize using a future block, and that's a completely separate issue, which I explained in the space today, we need both. So we need the 10,000 original Bitcoin cows to be hashed, and we need to be able to prove that it hasn't been tampered with. And then we need the randomization so that we can then distribute them in a fair manner. So the random seed will be taken from a future block, which means we have no idea what that number is going to be. So once you get the Bitcoin cows delivered to you, we can reveal to you this. The original ordering was this. You will be able to get every single Bitcoin cow according to the ordering. You will be able to then get the SHA-256 output. You will be able to then concatenate, join all 10,000 of them together, and then put it back into this tool, and you will find that the output that you get will be exactly what was written in the Ethereum smart contract before we did all the randomization. And therefore, it is provably fair. I know it was a bit of a long video. I hope it all made sense. I hope you learned something. Any questions, always jump in Discord and give us a tag, and we'll be happy to go into more detail. So that is it for today, and this is why it's so exciting to be part of the On-Chain Birds family, always breaking new ground, new technology, and this is the way that Bitcoin ordinals should be minted, so that they're transparent, provably fair, and a good experience for all. And this is why you should tell all your friends about Bitcoin cows and on-chain birds. And if you're if you're watching this video and you're not part of the family, we always welcome new members. So join up on our Discord, say hello, and come and join the On-Chain Birds crew. Thank you, and I will see you next time.